Okay, we're back, and you may have had to download Praat. You click the icon, it looks like lips and a tongue. And when you click on Praat, you're going to get these two objects. You're going to get a Praat object and a Praat picture. For our purposes right now, we are not going to need to use Praat picture. So I'm going to close that. So for the Praat object, you are going to be practicing recording and then analyzing a signal. What you want to do is go to New, Record Mono Sound, and this window that comes up, it's going to have mono, it's going to have 44100 Hertz. I'm going to tell you to title this right now, and I'm going to title it 1, 2, 3 test. And then I'm going to record. 1, 2, 3 test. Now I'm going to save to list. I'm not going to close it, but I'm going to go save to list. So now if I move this sound recorder out of the way, I actually have my recording and it's saved. So do that. So then if you want to view this sound file, you will do view and play. And so now you've got this beautiful sound file that has come up. And if you just look at this top part of the sound file, what you're going to see is the amplitude part of the file. So when I said 1, you can see my amplitude. 2, 3. I do want to show you some how you can manipulate this sound file, how you can look at it. So if I want to select a little bit of this sound file, actually I'm going to do it this way. Let's say I want to listen to my production of sound. I have selected it with this pink outlining, and then if I hit select, I now have isolated that pink part. You can now see that sound, that part of the sound file right there. If I want to verify that I have only selected the word 1, what I can do is click here on the visible part. 1. And there we do have the visible part. So again, I've kind of demonstrated to you how you can cone in, like zoom in and zoom out. But I want to come back and show you, again, this is the amplitude and this is the time. So amplitude is this way, time is this way. And this is the spectrogram. So now I have selected the OO in 2, and if I want to really look at that selection, what you see here is the T, that's the stop, and T. You do not see a voice band here, which is pretty cool because there's no voicing in the T. And then all of a sudden when I start to produce the OO, you see my voicing band here. Now the great thing about Praat is you can measure your fundamental frequency here. In your assignment, I really asked you to get me a close-up of a vowel. So let me show a close-up. We know that this is the T. This is the OO in 2. So to get that close-up of the vowel, I really wanted a couple of cycles here. So I would like a close-up of 2 to 4 cycles, and we know a full cycle is when the pattern starts to repeat. But when you go peak to peak to peak to peak, that to me would be 2 to 4 cycles right in here. So that's what I want you to take a screenshot of in the time domain. That shows me that you learned how to scope in and really go cycle to cycle. Remember, your time domain is this way, amplitude domain is this way. So I want a time domain representation and hopefully 2 to 4 cycles. And I asked for the ah and the e, and really I don't care. I just want you to learn how to do that process of scoping in and scoping out. So I'm going back to that. Again, we're at the word to. And I want you to think about the waveform of the shape of the vowels, and also look at this spectrogram. In this case, this is, you can tell that this is a stop to. So the air has stopped. There's no voicing. As I say ooh, look what my formants are doing. They for the ooh, my lips are coming out, and the formants are actually kind of echoing that visually. So you can see that, which I think is interesting. And I've asked you to look at what E and ah would look like. But in this case, I'm going to just show you the ooh. Let's see. The final thing I have for you to do is there's a little worksheet, a Praat worksheet. You have the choice of actually filling out the worksheet or filling out, so it's a summary report. It's the Praat summary report. Or I'll show you a shortcut, but it really would help, I think, if you did the summary report so that you kind of see the value of what Praat does. I'm going to go back for a second. We're going to return to Praat, but I want to talk a little bit about jitter and shimmer. But you've heard of jitter and you've heard of shimmer. Vocal jitter, so JF, you will hopefully remember jitter is frequency perturbation, and it's fundamental frequency perturbation. The system isn't just perfect. Your vocal folds don't vibrate exactly the same every cycle. So the frequency of a speaker's voice is going to vary a little bit from cycle to cycle. And there's what we call this random period variability. That's the frequency perturbation or vocal jitter. Jitter increases when people have a voice disorder, and it's responsible for the perception of a hoarse, harsh, or rough voice quality. And so jitter is a measure of how stable that vocal frequency is from cycle to cycle. Normal voices usually have less than 1% variability cycle to cycle. So we do have different types of jitter measurement. We have absolute jitter, and absolute jitter is the difference between the first cycle and the second cycle and the third cycle and the fourth cycle. Those cycles that are right next to each other, contiguous cycles. We don't always look at cycle to cycle variability, so we can look at mean percent jitter and jitter ratio. So mean percent jitter is taking the absolute jitter from those contiguous cycles and dividing it by the mean vocal period used during the phonation. That proportion is then multiplied by 100 to get a percentage of jitter. If that proportion is multiplied by 1,000, that's the jitter ratio. So we also have what we call the relative average perturbation, and that relative jitter measure, it's the attempt to reduce the effect of the long-term frequency changes. So if you've got slowly rising or falling pitch, and that compares the average of 3 cycles to a given period. So it averages 3 periods or cycles and compares it to the given period. So the average period difference is then divided by the mean period. Again, if we multiply that by 100, it's called the relative average perturbation percent. And then the mean jitter factor is the absolute difference between the sequential vocal frequencies divided by the mean frequency of phonation multiplied by 100. So we have a couple of different ways to measure jitter and get an idea of frequency stability from cycle to cycle. So again, in the olden days, we truly would have to look at the plot or the jitter and measure it out and then do that calculation. Luckily for us, Praat does it for us. There is another type of variability regarding vocal fold vibration, and that's amplitude perturbation. And that amplitude perturbation is very similar to frequency. It's just now we're looking at amplitude. So the perturbation of amplitude, or shimmer, is also an index of vocal stability. If somebody has too much shimmer, too much amplitude variation from cycle to cycle, they're also going to be perceived as hoarseness. We talked in class about when we think about frequency perturbation, that's how that's the repetition of the vocal folds and the timing of the vocal folds and how fast they're vibrating. But with amplitude, we thought about what is implicated in changes in voice amplitude, and we thought, well, you know what it is, it's air supply. So in some respects, we could say that shimmer is looking at the integrity of the respiratory system and how that may contribute to hoarseness. Just like jitter, shimmer has different types. So we can look at mean shimmer in decibels. That's the mean absolute decibel difference between sequential vocal amplitude peaks measured during sustained phonation. Or we can look at mean shimmer in percent, mean absolute cycle to cycle difference in that vocal amplitude, then divided by the mean amplitude by 100 to yield that percentage. And there is amplitude perturbation quotient, analogous to the RAP. The amplitude perturbation quotient attempts to kind of just normalize over long-term amplitude changes. It uses 11-point averaging, and it averages 11 cycles. I don't know why it's 11, but that averaging is then divided by, luckily again, our program Praat will do all of this for us. And so this is how we would calculate shimmer. Again, this is the old-fashioned way at looking at it over time and then doing our calculations. So I'm going to now show you how we can get these calculations using our program Praat. So here we are. I know I've selected out. So I have now selected out the vowel in 2. And what I first need to do is have Praat show the pulses. So when I do that, Praat now knows what to calculate. And then I can go from pulses, I can ask Praat to generate the voice report. And in this voice report, I'm going to pull this over so you can see it. You are now able to populate that worksheet that I gave you. I can see that my mean pitch was 183, or median was 183, mean was 185. Voicing and the fraction of voicing, it should be pretty voiced because it was a vowel. So yeah, only 2.38 was unvoiced. And then now I can get my jitter and shimmer ratings here. So my local jitter was 0.759. So my RAP for jitter was 0.287, not too bad. And my shimmer 4.735. That analogous reading to RAP is 1.87. So hopefully that I'm not in too big of an issue. I'm going to ask you to look for the fraction of unvoiced frames, number of voice breaks, the degree of voice breaks, and then I would like you to tell me the local jitter and the local shimmer. And then there's a mean harmonic to noise ratio. So this is the report that I am asking you to populate on the worksheet. Thank you, everybody.